name is Lana Jaco, and I have done my research on Newton's laws of motion. My main research is on Newton's third law of motion, but I thought it would be helpful if I gave a brief description of the first and second laws of motion. As you will see here in my PowerPoint presentation, Newton's first law of motion, an object will rest and remain at rest unless acted upon by an unbalanced force. An object in motion continues in motionless, the same speed and in the same direction unless acted upon by an unbalanced force. This law is often called the law of inertia. And here's just a brief picture of such. Newton's second law of motion requires force equals mass times acceleration. And lastly, Newton's third law of motion. For every action, there is an equal and opposite reaction. So in my research, I chose to use a battery-operated fan cart, and in doing so, I just needed a few simple tools. I needed batteries for the fan cart, a tape measure, which I measured up to 2 meters with a small little yellow tape, and a stopwatch. So I'm actually going to demonstrate first how the fan actually operates without doing anything to it. Hi, my name is Lana Jaco, and I will be demonstrating Newton's third law of motion. As you can see, I'm using a fan cart here as a simple device for demonstrating the action and reaction theory expressed in Newton's third law of motion. I made a measuring tape here, a handmade measuring tape measuring up to 11 feet. On the wall here, I have a tape measure, tape, stopwatch, Sharpie, and a pair of scissors. Those were the equipment used in my making this. As you can see here, we have a smooth level surface, and we are now going to turn on the fan cart. As I turn on the propeller, you will see the propeller start to rotate at a high speed. Note the direction of the airstream. As we release the fan, you will see it moving in the opposite direction to the stream of air, showing that the force is acting on the cart. Now in my second video, I placed a small deflector plate, which I just simply made of a little white piece of cardboard, and I kind of used that as a, not so much a balance, but for a little bit of weight, and to actually block the propeller, the air from flowing out of that side of the propeller. So you will see here what happens in the video. Now I am placing a deflector plate on the front of the fan. As you can see, I made a little homemade piece of thin white cardboard. So as I turn on the fan and release the cart, you will observe that the cart does not move. Well, at least it moves just a little bit, nowhere near what it did before. The reason for this is to accelerate the air. A force must be applied to it in the direction of acceleration according to Newton's third law of motion. It requires that an equal and opposite air is expressed by the body causing the acceleration. However, the expelled air strikes the deflection plate and its direction is changed. So I'm not quite sure if you could hear that in the video. The fan is quite loud, and I apologize for that. But with the deflector plate being in front of the propeller, it blocks part of the airflow. In return, it is restricting the airflow, and according to Newton's third law of motion, does not require, or does not actually allow it to have force, which in return the fan does not move. Now in the next video, you will see we took the deflector plate off, and we're actually measuring the force of acceleration. So we're gonna start here, and then you will see at the end a stopwatch. So we're gonna see just how fast it goes. Acceleration of the cart, which would give us the formula of A equals 2S over T squared, S being distance and T being time. As you'll see here, we have a stopwatch. I am now going to start it, and my assistant will start the fan cart. As you can see, is 5.4 seconds. We will plug this into the formula, and it will be attached in my PowerPoint presentation. So in my PowerPoint presentation, I just gave a brief description of all the tools, actually all the parts on the fan cart, and how you measure the fan. So S equals distance, T equals time. So 2S over 2 squared equals, and then I came up to 5.4 squared. The calculation of the force of the fan, F equaling mass, F equals mass and acceleration. So in order to do this, I actually had to weigh the scale, the fan on a scale in grams. So I had to convert the grams into newtons, and I did so. So these are just my simple calculations, and my conclusion is that the newtons of force were 302.162, and equal and opposite force do actually cause reaction. I hope you enjoyed my video. It was extremely difficult to make because this was my first time, but I tried my best. Have a great summer.